Today I will discuss about the projectile motion. So before going in detail about the projectile motion, first of all we should talk about the straight line motion and circular motion. So when we have velocity and acceleration in same direction, so we have straight line motion and velocity and acceleration in opposite direction, so we have straight line motion. So please notice this important point, that when we have velocity and acceleration in same direction, here angle between velocity and acceleration is 0 degree, and when velocity and acceleration are in opposite direction, means angle between velocity and acceleration is 180 degree. In this case we have straight line motion. So I expect that all of you are being very well explained by this explanation, that when we have velocity and acceleration in same direction or velocity and acceleration in opposite direction, then we have straight line motion. Now second one case is, we have velocity and acceleration in mutually perpendicular direction. So angle between velocity and acceleration is here 90 degree. In this case, acceleration always tries to maintain the moving object in circular path. So motion of the object here will be circular path. So in this case, when we have velocity and acceleration mutually perpendicular to each other, the path of the object will be circular. Now third one case starts, that case is projectile motion. So when we have angle between velocity and acceleration like this, and this is theta, and theta is not 0 degree, not 90 degree, and not 180 degree. So theta means angle between velocity and acceleration is other than these angles, means that theta between velocity and acceleration may be greater than 0 degree, less than or greater than 90 degree, less than or greater than 180 degree. In this case, the path of the moving object is like projectile motion like this. So we have the third case where object is projected like this with velocity v0, and this is the angle, and acceleration at this point, projection point, is g, downward direction. So we can see here that angle between velocity and acceleration is not 0 degree, not 90 degree, and not 180 degree. In this case, object had the path of projectile motion. So at different points, now here we can say that this is the velocity and this is the direction of acceleration, a y is equal to g. So this is the special case at highest point of projectile, where angle between velocity and acceleration becomes 90 degree. But other than this highest point, at each and every point in projectile motion, we have angle between acceleration and velocity, that is theta, and that theta means angle between velocity and acceleration differs from these angles. So when angle between acceleration and velocity is different than 0 degree, 90 degree and 180 degree, in that particular case the path of the projectile object is projectile motion. So I have discussed here three cases in which In first one cases, acceleration and velocity are in same direction. In second case, acceleration and velocity are in opposite direction. So path of the motion of the object is straight line. In second case, we have velocity and acceleration mutually perpendicular. So path of the object is circular. This is circular motion. And third one case is where angle between velocity and acceleration is like this, not 0 degree, not 90 and not 180 degree. So in this case the velocity, projectile path of the object is like this and it is known as projectile trajectory. So today I will discuss about this third one case, means projectile motion. So let us start about the projectile motion. So I have discussed about the projectile motion, that what is the case in angle and acceleration when projectile motion starts. So the case is that theta not 90 degree, theta not 0 degree and theta not 180 degree between velocity and acceleration. So the path of the object will be projectile motion. So we have here projectile motion trajectory. So I have projected an object from projection point with velocity v naught and angle of projection is theta. So at projection point, angle between acceleration and velocity is here. We can see that this angle is 90 degree plus theta. So we can say that at projection point of projectile is also angle between velocity and acceleration is 90 degree plus theta, which is not 0, not 90 and not 180 degree. Now when we have this point of projectile motion, so velocity is here v and acceleration is vertically downward. So once more here angle between projectile motion is theta and it is not 0 degree, not 90 and not 180 degree. So this is very important to notice that in projectile motion angle between acceleration and velocity is generally not 0 degree, not 90 degree and not 180 degree. So this angle is other than this angle. So this is the case of projectile motion. So in projectile motion we have different parameters. So these different parameters are flight time, maximum height, range and equation of trajectory. So let us now discuss about the different parameters of projectile motion. So this is the projectile motion trajectory and we have here initial velocity v naught. So different parameters of a projectile motion are, first one is time of flight, capital T, and this is 2 v naught sin theta upon g. Capital T is equal to 2 v naught sin theta upon g. Second point is height and it is v naught square sin square theta upon 2g. And third one point is range, and it is V naught square sine 2 theta upon G, and third one is the equation of trajectory of projectile motion. So equation of trajectory of projectile motion. So this is y is equal to x tan theta minus gx square upon 2 v naught square cos square theta, or y is equal to x tan theta 1 minus x by r. So these are the different parameters of projectile motion. So now step by step I would like to discuss these parameters of projectile motion. So let us start about this discussion about the different parameters of projectile motion. So in projectile motion we have some assumptions. In projectile motion, first assumption is that air resistance of atmosphere is neglected, that is negligible. And second one is the rotational motion of earth is also neglected, and curvature of the earth is also neglected in projectile motion. And in whole through the motion of projectile motion, we assume that the value of gravitational acceleration g remains constant. So these are the assumptions in projectile motion which should be applicable. So under consideration of these assumptions, we start here derivation of projectile motion of different parameters. So this is the projectile motion trajectory. So this is y and this is x. So here we can represent that this is the projection velocity, and this projection velocity is v naught, and this is projection angle. So at this projection point, horizontal component of velocity is v naught cos theta, and vertical component of velocity is v naught sin theta, and it is known as vy. So these are the components of velocity at projection point. So this is v naught sin theta. So we generally discuss about the point that horizontal component of velocity along the whole through the motion remains constant in projectile motion. So this is very important point to notice, that in projectile motion horizontal component of velocity remains constant in whole through the motion in projectile motion. So now we will discuss about the flight time, time of flight. So time of flight is the time taken by projectile during whole flight. So this is capital T. So let when projectile is at this point, so vertical component of velocity here becomes 0, and time from projection point to this point is equal to t by 2. So from equation v y is equal to ui minus g t, when t is equal to capital T by 2, Vy becomes 0 at highest point. So we have here V naught sin theta, because this is initial projection velocity along y axis, minus g into t by 2. So from this equation we have time of flight 2 v naught sine theta upon g. So this is time of flight, and time of flight becomes maximum when projection angle is 90 degrees. So from this equation we can see here that T max is 2V naught by G when theta is equal to 90 degree. So this is the flight time of projectile motion, and this can also be written as V 2Vy upon G, where Vy is equal to vertical component of velocity at projection point. So next one explanation is about maximum height. So at highest point we have vertical component of velocity equal to 0. So height obtained by this projectile motion at this highest point is equal to h. So this h is also calculated by equation v square is equal to u square minus 2gh. So at highest point h equal to capital H and Vy becomes equal to 0. So from this equation we have 0 is equal to Vy square means V naught sine theta whole square minus 2 capital H G into capital H. So from this equation we have H is equal to V naught square sine square theta upon 2G. So this is the height attained by maximum height attained by the projectile motion during its projectile motion. So H max is equal to here once more V naught square upon 2G when theta is equal to 90 degrees. So projectile motion is having its maximum height from the ground when its projection angle theta is 90 degrees. So that is why when we want to project any object up to the maximum height, we project it in vertical direction with horizontal, means at 90 degree with horizontal. So this maximum height can also be written as Vy square upon 2G. Now I will discuss about the range of the projectile motion. So for range we have this value. This is the range of projectile motion. So range is equal to nothing but ux into flight of time of projectile motion, and in x direction no acceleration. So in x direction velocity of projectile motion remains constant, as I have already mentioned here. So horizontal distance covered by the moving object during whole flight time is known as range. So this is V naught sine theta, and I have already discussed about the time of flight. This is 2V naught sine theta upon G. Sorry, this is not sine theta, it is cos theta. So after calculation we have V square 2 sine theta cos theta upon G, and this value 2 sine theta into cos theta is equal to sine 2 theta. So range becomes equal to V naught square sine 2 theta upon G. So this range can also be written like 2Vy Vx upon G in vertical and horizontal component of velocity at projection point. So this is the relation for range. So a range can also be maximum V naught square upon G at theta is equal to 45 degrees. So range of projectile motion is maximum when projection angle is 45 degree with horizontal. So these are the different parameters of projectile motion. Now I would like to discuss about the equation of trajectory of projectile motion. So equation of trajectory of projectile motion. So we have this trajectory path of projectile motion. So let this projection angle is theta and projection velocity is v naught, and let our projectile is at this point. So this point is represented as x, y. So coordinates of these points are like this. This is x and this is y. So and time taken by projectile to come from this projection point to this point is small t. So x can be written as Vx into t, and Vx, we know Vx is equal to V naught cos theta and Vy is equal to V naught sin theta. So this relation can be written as V naught cos theta into t. So from here t is equal to x by V naught cos theta. Now we can calculate from this y is equal to vertical velocity into t minus half g into t square. As we know that in vertical motion of projectile only gravitational acceleration is applied there. So in vertical direction acceleration is ay and this is minus g. So this relation can be written as y equal to v naught sin theta, and from here we will put the value of t. So this t is x by v naught cos theta, and this is minus g by 2 into t square. T square means x by v naught cos theta whole square. So we have y equal to from here x tan theta, v naught cancelled out, so this is x, and sin theta by cos theta is equal to tan theta, and here this is dx square upon 2 v naught square cos square theta. So this is the equation of trajectory in projectile motion. This can be also written as x tan theta 1 minus x by r, as we take here x tan theta common, so this relation becomes like this. And this equation of trajectory motion can also be written like that, this ax minus bx square, where a and b are constant. So we see here that relation in y and x is quadratic, and that is why equation means projectile path of the projectile is means trajectory is parabolic in nature. So I have discussed different parameters of projectile motion. So some points are other also here very important. So I would like to discuss this point here. So when we project any projectile at two different angles, this is x and this is y, this is angle alpha, and other angle of projection is like this is beta, and if alpha plus beta are 90 degree, then range in these two cases r alpha and r beta is equal to r, and projection velocity in both cases let v naught. So this is v naught square sine 2 theta upon g means sine 2 alpha, or v naught square sine 2 beta upon G, and T1 and T2 flight time in two cases is equal to 2R by G, and height relation is also H1 by H2. We can write here V naught square sin square alpha by 2G upon V naught square sin square beta upon 2G, and we know that beta is equal to, from here beta is equal to 90 degree minus alpha. So this relation becomes cos square alpha. So this is also equal to ratio of tan square alpha is to 1. So these are the different parameters. Here height maximum H1 and here height maximum H alpha, and this is H beta. So these are the different parameters in projectile motion. I expect that all of you are getting very well explanation in this representation of projectile motion. So meeting in next video. Till then, thank you.